discuss the last part in the hydrostatics, which is Pascal's principle. Pascal had decided to conclude some principle to maintain a fixed conditions for pressure application on incompressible liquids. So he assumed at first that if we had a container like this with some fluid and a piston on the top of this fluid, he decided that on adding much pressure, such that moving this piston down or adding an external weight, he discussed that the pressure of all the added issues, all the added stuff is transmitted in full to all parts of the liquid as well as the walls of the container. This means that the pressure comes here and here and here in all directions, acting like this and acting like this, acting on the walls of the container, and it is transmitted in full. As we can see, when the pressure is applied on a liquid, where this liquid is enclosed in a container, the pressure is transmitted in full to all parts of the liquid as well as the walls of the container. But we had to keep in mind that the liquid must be incompressible. Why should it be incompressible? To avoid the pressure exertion that can be diminished. So if I have to ask you a question, give reason for Pascal's principle is not applied to gases because gases are compressible. So the pressure exerted will be transmitted and diminished. Um, let's move to the next part. The application of Pascal's principle was the hydraulic press. The hydraulic press or the car lift, the most famous device to move something heavy upward, like the car to replace a car tire or something like that. We apply Pascal's principle here by finding the pressure to be transmitted from one point to another. Well, he brought a small piston like this and a large piston like that. On applying the small force on the small area, we got a value of pressure, F over A. On the other side of the hydraulic press, we are about to receive a large amount of force due to the large area. This is why, this is because the pressure on the large piston equals to the pressure on the small piston, and keep in mind that it is written in this way to be pronounced with N, not L, not M, piston. Okay. The pressure on the large piston is the F over A, and that of the small piston is F also over A, but of the small values. This means that the large force, the large amount of force which came from the constant value of pressure was multiplied by a factor which is the capital area over the smaller area. This means that the value would be amplified to enlarge the force acting on the small piston. For example, if we have a small force of 10 Newton on a small piston, an area of large piston was 500 meters square, while that of the small piston was 5 meters square. What's the force taken from the large piston? Okay, here we go. F equal a capital A over a small times F small, 500 over 5 times 10. It means that the value of the 10 Newton was multiplied and amplified to 1000 Newton. This means that the large force which came out of a small force using the advantage of ratio between the areas of pistons, that's why we call it mechanical advantage, and we take this letter which is called eta and is written like that. Okay, let's move to the next part. According to the law of conservation of work and energy, that energy and work is not lost nor created, but can be transformed from one form to another and can be transmitted from one form to another. Here we go for small value of f that has to move long distance, a large number, great number of distance from one point here to one point there, just to make the large piston to be moved from here to there. And this was shown when you are trying to lift your car to replace your car tire, you have to move the arm that you are carrying in your hand more than the distance displaced by the body of the car. This is simply decided because you are acting on the small piston, of course, because your average force and average internal and entire energy and power of your body that cannot carry the body of the car without the help of the hydraulic press, of course. For the work on the large equals the work on the small, this means that F capital equals, F capital times Y2 equals F small times Y1, then F equals Y1 over Y2. This is the only situation, this is the only special case in the hydraulic press applications that the small piston made a greater number than that of the large piston. Here we go, we can decide that the mechanical advantage, it is the ratio between the large force and the small force, the large area and the small area. And the area moved by the small piston, it's the only small piston over the area of large piston. That's because the y of the small is greater than that the y of the large. We are seeking for the value of mechanical advantage greater than 1. Of course, you are using this hydraulic press in order to multiply, in order to increase the value of the force needed, not to destroy it. Okay, and the area is pi r square over pi r square. We can do like this. Then r over r square. The ratio between the radius and radius is the same as that between diameter and diameter. We had to cancel it with each other, and the velocity, of course, of the pistons. For the mechanical advantage, it is the ratio between force of the large and the force of the small, the ratio between area of large and area of small of the same stuff, the ratio between the distance moved by the small and that of the large one, which means that again for the second time, small greater than y large. Okay. The application is the car lift. You are pressing like this and it's transferred to this piston, and this piston of course is under the body of the car. And the brakes, of course, the car brakes takes the same concept and the same principle that you are pressing on a small area just to stop a part like this of large area. The dentist chair, when you are sitting here, the dentist uses this part to press on, just to make this part up or to make this part up or to make this part like this. This is a hydraulic system using the concept of Pascal. He is only pressing on pistons applied to incompressible liquids in order to transmit the pressure to another pistons of different areas according to the required values and the required data. Just in case if the starting position was different, was not at the same level, of course we have to remember that the pressure in the small in this situation will be the pressure, the large piston plus rho g h. I think we have to move for some practice. Uh, let's start with page 50, I think 8. right, 58. The cross-sectional area of the small and large are 40 and 2000. Force of 100 applied on the small. What? Find the mass which can load on the large piston, and what is the mechanical advantage? Okay, the mechanical advantage, of course, would be the A capital over A small, 2000 over 40. Of course, in the our usual routine, we have to convert it into meter square, but it's up to you if you don't like to convert it, because this value had to be called off like that. So either you had converted into meter square or not, I don't care because it is ratio. Okay, then the mechanical advantage equals 50. Also, the mechanical advantage equals F over small f, then 50 equals F over 100. Then the force of the large piston will be 5000 Newton. Then mass equals force over gravity, 5000 over 10 equal 500 kilogram. Of course, this is the weight, which is Fg, which is mg. I think we can move to another one. I prefer number 3. Number 2 is the same as number 1. A service car station uses a hydraulic car lift. The diameter of its compressed air tube is 2 centimeter, and that of the large piston is 32 centimeter. Calculate the force needed to raise the car off this mass. Okay, I think this will work better. According to the givens, this is the car. The greater value will be for the car 1280 times 10 over the force acting equals 32 over 2. Do I have to convert? It's not an important matter here in this type of problems. Square. Using your calculator, we can find that F equals 2 power 2 times 1280 times 10 over 32 power 2. We can find it 50 Newton. Okay. Number 6, it would be the last one. The small area was 10 centimeters squared. The force applied, this means that the small f and the small area, the cross-sectional area of the large is 800, and here is G. Number 8, we needed to find the mechanical advantage. Eta equal A over A, 800 over 100, sorry, over 10, 10, not 100. The value is 10 here, equals 80. It is unitless, has no unit. Number B, the maximum mass. I think eta equal F over small f, 80 equals F over 100, then F equals 8000, then mass equals F over G, F over G, this means that 800 kilogram. The last one, distance moved by the small piston to move the large by 1 centimeter. Eta equals y of the small piston over y of the large piston. 80 equal y small over 1, then y small equals 80 centimeters. Here we go for the last part in the hydrostatics. Hoping that you had enjoyed this part and wishing you happy times and wishing you to stay safe. And bye bye.